Welcome to ClickMyProject.com. Our project title is the Channel Estimation and User Location for the IRS-Associated MIMO and OFDM systems. This is an abstract. Multiple input and multiple output orthogonal frequency division multiplexing system supported by the intelligent configurable surfaces. We explored the channel prediction problem and channel-based wireless application. We suggest a unique twin IRS structure made of two IRS planes with a relative spatial rotation in order to get the channel characteristics such as angles, delays and gains. Okay, for the environment mapping and user location, we characterize the training signal as a third order canonical polyadic tensor with the maximal tensor rank equal to the number of IRS unit cells traveling from the user equipment to the base station through IRS. In this design, we design a OFDM signal with the OFDM simulator for the waves. This is our block diagram. First block is the random data generator. From the random data generator, we move on to the modulation. In the transmitter side, we do the modulation with the BBSK, QPSK and 16 QAM and 64 QAM. In this process, we use the BBSK, that is pulse shift keying, and then serial to parallel converter. We got the serial data in the modulation process and we have to convert the serial to parallel data. From the parallel data, we move on to the inverse Fourier transform series. This is the inverse fast Fourier transform. Here we done the fast Fourier transform process for the parallel data and then parallel to serial converter, and then one interval we have to insert our transmitter side. Then only we have to move on to the channel model. Here our channel model is the AWGN, and then move on to the next receiver side. Here first process is the addition of the interval is removed in the receiver, and then serial to parallel converter. Here we use the fast Fourier transform, is the inverse process of the transmitter, and then parallel to serial converter. In receiver we done the demodulation technique and then we got the output data. This is our main code for the OFDM simulations. By click the right click and go to the run option, we have to run our main code. And this is a impulse response. Likewise, our first module is generate the random impulses. That is the first one. Then second figure was the 12 subcarriers. Each impulses have the 12 subcarriers. And third figure is the OFDM with the 600 subcarriers. These are done with the modulation process. Here we use the BBSK modulation technique. And this is the OFDM demodulator signal in the pilot format. The plus symbol is determined as the OFDM piloted signal. The RMS value and the peak value and the average value, peak value, average value, these are calculated from this figure. And then figure number 4 is the FF50. This is the demodulation technique. This we have the FF50 1024. And then final one is the demodulated signal of the OFDM signal. This is with the quadrature amplitude and in the phase amplitude. And finally in our command window we have to find the peak to average ratio for the FFOADM is 11 decibel, and then is the OFDM, normal OFDM is 9.2 decibel, and the FOFDM reception BER, bit error ratio, that is point something, and SNR, what about the SNR is 18 decibel, and then BER is 0 at 12 decibel.